Go through review packet number 3. Again, anything in review packets 1, 2, 3, and the worksheet number 4, guaranteed you're going to see things like this on the final. Review packet number 5 is kind of long, but I very strategically chose things for you to practice as well. So let's take a look at this. This is the key. Sketch the graph of this guy. Now, when I look at this, it's e to the x, so it's an exponential function. Do you want to get this in the correct format? So I'm going to write f of x equals, I'm going to write the negative 80 e to the negative x, and that would be plus 80. So I always like to take the equation, just like I did with the trig equations, I put them in the correct order. Now, for both these and log graphs, what I want you guys to do is come up with the parent function. So if you stripped away all the extras off of this, what would be the most basic question? And that would be, my pen's breaking, y equals e to the x. And what I want to do now is come up with an x and y chart for the parent function, and then we're going to manipulate it. So x, y, I always recommend 3, and if you notice here it says at least 3. So I always do, now see, check out what letters in the exponent, the variable x here, so that means I'm using this as my my starting point, so negative 1, 0, 1. E to the negative 1, it would be 1 over e. E to the 0 power is 1, and e to the first is just e. So now I take, one other thing, the asymptote. The original asymptote is going to be y equals 0, and that's true for all exponential functions. Now we're going to change this up, right? Going to multiply all 3 of these by negative 80, all 3 of the y's. So this becomes negative 80 over e, becomes negative 80, and this becomes negative 80e, right? Then we go to the x, and we're going to negate those. That becomes positive, 0 stays, and that becomes negative. And then onto these guys, we're going to add 80 onto the y's. So we're going to do plus 80, plus 80, plus 80. All right, so for f of x, I'm going to put it over here now. The x and y's we want to plot, right, would be positive 1, negative 80 e over e plus 80. This would be 0, 0. And this would be negative 1, negative 80e plus 80. All right, so this is what we're going to plot on our graph. And these will be the points. All right, so the easiest thing to plot is going to be 0, 0. And no, I can't mess that up. Now, take a look at the old asymptote, which is y equals 0. We do want to get the new asymptote. I like to get that on immediately. So the new asymptote, it's still going to be y equals. So any adjustments we made to the y, we have to make to the asymptote. So you notice we multiplied first by negative 80, right? 0 times a negative 80 is 0. And then we're going to add on 80. So the new asymptote is y equals 80. So I'm just going to do this, guys. Boom. 80. And go straight across. All right, now I got to plot these 2 points. So I need to know approximately where they would be. All right, so let's start off with negative 80 over e plus 80. E is approximately what? E is approximately 2.8, or you can even round to 3. We just need a ballpark. So negative 80 divided by 3, let's say, is approximately negative 26 plus 80, right? So that's going to be approximately in the 50s. So at 1, which would be here, right? Maybe a little more than halfway up. Guys, we're just ballparking it, right? And then the other one is negative 80e plus 80. Well, if e is about 3, this is about negative 240, right? Plus 80. That means this would be approximately negative 160. So at negative 1, we're going to be like way down here somewhere. So the graph looks like this, and we're going to asymptote. And all you got to do is label these. This is 0, 0. This would be 1, negative 80 over e plus 80. Again, we're just ballparking. And this guy would be negative 1, negative 80e plus 80. And there you go. Doesn't have to be perfect. And if you do these charts, I can literally follow along your thought process, and I understand what's going on. All right, now number 2. For this next section, you have to identify the graph and come up with an equation. And when you're looking at this, I hope you realize it was a polynomial. So that's a polynomial function. Basically, know it's a polynomial function anytime it has bounces and plateaus. So we got a plateau here. We go through here. All right. Now, to come up with the equation, and you know it's a polynomial, we're going to start off by writing y equals a. The biggest mistake in these is everyone forgets the a. We need to come up with that, but that's going to be the last thing we do. Then I go to my graph, and I look at where it hits the x-axis. Notice it hits here at negative 5. So that means we have a parenthesis that's x plus 5. And then I notice it went through the point. So that's to the first degree. Now, it also hits here at negative 2. So I'm going to write x minus 2. But notice it flattens out or plateaus. That means I'm going to give this a cube. And finally, it hits at positive 2. So that's going to be x minus 2. We go through the point. So it's going to be 1. So that's our starting point. Now, somewhere on the polynomial graph, there should be another point, which is this guy. Now, we're going to plug this in for x and y to figure out what the a is, what we call the shape factor. So y is going to be negative 40. Okay, I'm going to do 0 plus 5, 0 minus 2 cubed, 0 minus 2. We get negative 40 is a. That'd be 5. That'll be negative 8, and that'll be negative 2. So this becomes negative 40 equals a. That becomes, let's see here, negative 40, right? Negative 40. Oh, I caught a boo-boo. That should be x plus 2 right there, because that's a negative 2. That's a plus 2. That would be positive. So this would be negative 80. Okay. Divide both sides by negative 80. Glad I caught that. And then there's 1/2 equals a. All right. So now a is a half. So the final answer to this question, we're going to put it all together, would be y equals 1/2 x plus 5 to the first, x plus 3 cubed, and x minus 2. And there's 2a. So you should have had polynomial, that's a part of the answer, and then that equation. All right, let's see what's next. All right, now I don't know about you guys, but that's screaming trigonometry to me. So that's a trigonometric graph. So I'm going to write trigonometric. Okay. And I just want one equation. Actually, I'm going to do 2. I'm going to make both a sine and a cosine, just for practice. Big thing with trig. The very first thing you want to find is the midline, right? So what would be the center of this graph? This goes 6, negative 2. Basically, if you average those together, the highest point and the lowest point, you find the middle. But I think it's pretty obvious it's at 2. So for trig, you always want to find the midline first. So I'm going to do y equals y equals. I'm going to do one for sine and one for cosine. There's going to be lots of different answers for this. But now that I know that this is 2 at my midline, you know, so I'm going to do a sine, cos. Both of them are going to have plus 2 on the end. All right, next thing I find is the amplitude, the number out in front. And you notice from here to here is 4, right? From here to here is also 4. It's a good check to make sure you didn't mess up your midline, to make sure they're both the same. So we're going to be 4. Okay. Now, the hardest thing usually is the frequency, so I'm going to save that for last. What I want to do now is find the shifts. All right, sine. Sine starts on the midline. So you notice that's why I like to draw on the midline, this red line. So we have a couple different options for sine. Here, 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 and here can all be sine equations. The easiest one to use is the one that actually hits on the y-axis. That means you could just put a plain old x there. But notice how it's going down. That means I need to make it negative. So you could do that, or you could pick any other spot. But notice, see how this is labeled, these guys? It might be a little bit easier if we not use these guys, but if we wanted to, see that this whole cycle is 7 pi. So that means right here would be 7 pi over 2. It's halfway to 7 pi. So if you wanted to use, for example, this point, you would use negative 4. Oops, I don't know why I put that so far over. Sine, blank spot, x minus 7 pi over 2 plus 2. Because it's halfway to here, I put 7 pi over 2. All right, now, cosine is typically the highest point. So cosine highest or lowest. So you could use this for cosine. So anything I'm marking a blue point, you could use for cosine. Basically this blue point here, the low point, is halfway to this guy. So that means this would be at 7 pi over 4. Okay, so notice it's a low point, so it would be negative x minus 7 pi over 4. Finally, you need to find the frequency. Now there's lots of other answers, guys. You only need to come up with one equation. So you kind of find the one that you like the best, you do it. All right, now, trickiest part is to find the B, the frequency. And in order to do that, we need the period formula. Period is equal to 2 pi over B. So we need to find the period in order to get B to put here. The period is one complete cycle, so it could be the distance from low point to low point, or high point to high point. In this question, let me grab my marker. It's actually easier to use the sine curve, which is right here. Right? How far is it from the beginning of the sine curve to the end of the sine curve? Well, that distance is 7 pi. So I'm going to do 7 pi over 1 equals 2 pi over b, and I'm going to cross multiply. 7 pi b equals 2 pi, divided by 7 pi, b equals, and the pi's cancels, 2 over 7. So this would be 2 over 7, and that would be the same thing for all of them. All right, so for this question, you only needed one equation. You pick whatever one makes you happiest and go from there. All right, letter C. What kind of graph did you think that was? Well, that's exponential. All right, and the exponential function means we're going to use y equals ab to the x. So we got to make sure we use that. And basically we need 2 points to do this. Now we see this point right here. What's another easy point? I'm hoping you guys notice this. Just watch your scaling. See how that's a 2? 2, 4, 6. So that's the point 0, 6. Now, the magical part of this question is I gave you 0, 6. That's the one you should start with. It makes this question super easy because I know y is 6, a, b to the, that's 0, right? Well, what's b to the 0 power become? 1. So look right off the bat now. I know a has to equal 6. So y equals 6, b to the x. Then you take the other point, plug into this. 27 over 8 equals 6b squared. All right, so I'm trying to get b squared alone. So what I'm going to do now is multiply both sides by 1/6 so that these cancel. This pen keeps breaking. So I get b squared equals, and now here I'm going to reduce this, right? 6 and 27 have a 3 in common, so that becomes a 2. That becomes a 9. So I end up with 9 over 16. Take the square root of both sides, right? And that becomes 3/4 equals b. So the equation for this one is y equals a was 6, 3/4 to the x. And that's that one. All right, what's next? All right, now, letter D. As soon as you see vertical asymptotes, this sucker's screaming rational. It means it's got to be a fraction. All right? So this is going to be a rational function because there's a vertical asymptote. So I know I'm going to have a fraction. So y equals fraction. Now, I start with, right, what would make the denominator 0? And that's the vertical asymptotes. Notice it hits here at -1. That's x plus 1. Can go there. We also have a vertical asymptote at x equals 3. You can put an x minus 3 there. Now, if you guys remember when we did this, what did we do with the numerator? What's the numerator always give us? The numerator always gave us where it hit the x-axis. Notice it hits the x-axis right here, which is x minus 2. And that is enough for me for a rational expression. If you can find out the numerator and the denominator, that is fine. All right, next one. All right, now, technically, this is a power function, but it's also considered a rational. So this would be power/rational. And the reason why I say that is because there's a vertical asymptote here. Everybody see that? And I'm going to show you 2 different ways of doing this. But because they gave us 2 points, right? Because they gave us 2 points, I'm going to handle it as a power function. And I'm going to explain why they're kind of connected. That's y equals k x to the p. So anytime you've got 2 points, it's a power function. The only reason, and it looks funky like this, and it's not exponential, the only reason I'm not calling it, we could still kind of call it a rational, is because of this vertical asymptote. So let's check this out here. So we are going to compare these. So I'm going to do -1/4 equals k to the p. Now we're going to compare it to -16 over k, 1/2 to the p. All right, so the k's cancel. Now, if I flip this, -1/4 times 1/-16, right? I get positive 1/64. This is 1/64 equals. Now, this would be something to the p. Well, I'm going to flip this as well. So 2 times 2, that becomes a 4. Now, can we make these common bases? Yes, we can. 4 cubed, right, makes 64. This would be 4 to the -3, because the negative flips it, equals 4 to the p. So p equals -3. Now, y equals k x to -3. Pick one of the points. Doesn't matter. How about this one? The first one. -1/4 equals k 2 to the -3, which makes -1/4 equals k to the 1/8. Got to get k alone, so I'm going to multiply this by the reciprocal. So I end up with k equals, well, -1/4 times 8 makes -2. So my equation here is y equals -2x to the -3. So that would be our power function. Now, the reason why I said it could also be rational, guys, is what does a -3 do to the x? Where does it actually want to live? Down in the denominator. So because of that, that's why it's like a 2-pronged. Technically, both of these are correct because that x to the -3 landed us in the denominator. Okay. And finally, f here is another polynomial. Okay, so I'm going to start setting up y equals a. It hits at 1, 2, 3, 4. This is at negative 4, so I'm going to do x plus 4. Went through the point, so this is the first. It also hits at negative 2, so we do x plus 2. It bounces, so I'm going to put a squared. It also hits the x-axis here at positive 2. And does that flatten out a little bit? It looks like it might, so I would say it's a 3. Okay. So now pick any other point, which we see right there. That's the point 0, 2. So now I'm going to do 2. Then it'll be 4, 2 squared, negative 2 cubed, 2. That'll be a. This will be 4 times 4 times negative 8, which is negative 128a. So divide by negative 128. I get negative 1 over 64 equals a. So y equals negative 1 over 64, x plus 4, x plus 2 squared, and x minus 2 cubed. Voila! Now, something to keep in mind, a little check. See how this arrow's going down? That means this has to be negative. If we go back to the very first one we did with the poly, let me find that guy. Notice this very first one here. See how this arm is going up and our A was positive? So that's another little check you can do. So that is the graphs.